there we go. All right. I should get some headphones. So, anyways, hi there, folks. You know what? I need to switch this to that. There we go. Little inception going on here. So today, let me turn that down. Today we are going to upgrade this beast right there. You can see that mess down there. That mess right down there. That is a Ramps Mega combination with a whole bunch of other circuitry for the hotbed and the LED lights. We're going to replace that today, or at least the core electronics, with a Duet Wi-Fi, which I picked up this week. There it is right there. That is the Duet Wi-Fi. So we're going to replace that hot mess down there with this. First thing we need to do is take a look at the documentation. So let's take a look here. So I don't have the chat up and running right now. I can't see it. I'm actually on, well, this is my server room slash laundry room slash 3D printer room. This setup only has one screen on it. I don't have a second screen in order to be able to see chat. I will check it periodically, but if anybody has any questions, just drop them into chat, and eventually I'll take a look. So what I picked up, this is the Duet Wi-Fi. I bought it off of, actually got it through Phyllis Struder here in the States. There we are. Cool. So anyways, I picked this up, and I also picked up the PT100 board, because eventually I'm going to replace the hot ends with the standard V6 block with the PT100 thermistors in them. But for today, I just want to get it up and running if I can, or at least get closer. So what I want to do is take a look at the wiring diagram and compare that with the Ramps wiring diagram, which they just happen to have right here. Sorry, this is the first, we're going to be reading a lot here. I haven't had a chance to review all of this, and this is more of a test of my setup to see if I can actually get a live event to work more than it is to be a how-to or anything like that. Alright, so 1224. I do know that the Duet Wi-Fi has only got a single power input versus the Ramps having two. Which isn't going to probably be an issue because I've got the bed split off to a second rail on the power supply anyways. I'm pushing, it's one of Maker Farm's 12-inch 12-volt heater PCBs, and it pulls a pretty decent amount of amps. So I'm guessing the MOSFET on here is not going to handle that. So I'll probably continue to run the heated bed off of the MOSFET circuit that I built for it. So single rail on the Duet Wi-Fi should be plenty. But what I will probably do is use the hotbed connections on here and drive the MOSFETs on there with that. The thing I got to watch out for is if that's going to be fast enough. But I'm only doing bang bang anyways, so it shouldn't be an issue. Do not connect the heater PS Plus to the Duet. That's good. End stop are running off of 3.3 volts versus the 5 volts. That isn't going to be a problem except for the inductive sensor that I'm running on here. I will probably have to build a 12 volt circuit for that and use some resistors and make a voltage divider for that so I can not only power this, but then drop the input voltage down to the 3.3 volts. I do have a couple of line level converters I could use on it, but that seems a little overkill when a resistor setup should work just fine. The other issue is that the end stops I'm running, you can't see any of them here, but there's one on the back of the carriage here. There's one here, and then obviously this one here for the Z-axis. These have all got LEDs on them. I don't know if they're going to continue to function at 3.3 volts. I guess we'll find out. I guess if they don't, it's not the end of the world. It is nice to know when they're triggered though. So. Duet has a single end stop for each axis, or ax, yeah. You can configure it for high or low. We'll configure all of ours for the low end stop. Let's see. Stepper motors are wired the same except for Z, which is done in series versus in parallel. On here, let me move this over. On my CBOT, if you can, please excuse the messy wiring. I got it up and running last spring, and I never came back and finished up the actual wiring. Let's see here. But the Z steppers, I've actually got them wired in parallel right now in the wiring harness itself. So I might need to break that and separate the two, because I've got two Z stepper motors for the Z-axis. You can see here the two lead screws. We got one in the front, one in the back. They're both driven by a they're individual stepper motors. And since I've got the wiring done in parallel, and they're saying to do it in series, I might need to break the wiring and put new ends on those, which is not a big deal. So, not a problem. Z probe, analog input, that's fine. Okay, we probably won't use the Z probe. We'll probably use the Z end stop instead of the Z probe output, because we don't need an analog. The inductive sensor is just going to be an on-off. Anyways, it's digital. And support for LCDs. And I do have, let me grab it right now. Now I did pick up a 7-inch touchscreen for the Duet, but I see that I must have missed a note somewhere, but this has got male ends on it, so I'll need to get the ribbon cable to connect this with the actual Duet, which is not a problem. I just won't be able to do it tonight. Let's see, put that someplace safe. Okay, so for wiring, I don't think there's going to be a real big problem other than the Z steppers. We're going to have to separate those out and put new wiring harnesses on there. They were kind enough to send the ends and the terminals for the wiring. It just so happens I'm already using these on my wiring in prep for actually using a BeagleBone, a replicate BeagleBone right here with machine kit. But the ramp setup worked so well, I never bothered to try it. I also have a cramps board with a, if we move the camera up here, I also have a cramps board, which is another BeagleBone, and then it's basically a ramps replacement, also for use with machine kit. The replicate can use the Python firmware, or the Python app. I can't remember the name of it right now, but Elias Bakken created the replicate. This is Gen 2, I think, and I think they're up to Gen 3 or Gen 4 now of the replicator. Nice board, 8825 drivers on there. I have had it up and running. Had some problems with it, with the motors that I had. It liked to make them squeal, and I wasn't able to figure out how to change the decay mode on these to fix that. So I went back to the ramps board, which is also using 8825s, but the decay mode is different on that, so it didn't have the squealing noise that these did. So anyways, so what I'm trying to say is that I've already got the ends, or I've already got the connectors that I need to connect the Duet Wi-Fi on all of my steppers. So there shouldn't be a problem there, and I'm just using the standard I'm already using these connectors for my end stops as well, so it literally should be a plug and play, even with the Z. I don't have to rewire Z to change it to in series versus the parallel it's in right now, but I would like to do that if they're saying it's better off. So, all right. And I don't know if you folks can hear me all right. Let me check. It looks like it might be kind of quiet, but all right. So I think we are good to go. The other question that I had is I don't know if this has GPIO pins that I can hook into for the LED lights. I'm assuming it has extra MOSFETs for. Let's see. You've got. Let me just look at the documentation here. Firmware differences. Where is the, there it is, there's the board. Powering, extruder heaters, fans, okay. Always on fans, we're not going to have, well, we'll have one of those. Yeah, we're going to do, they're 12 volt fans, so. Thermostatically controlled fans, are all the fans? Let's see here. Wi-Fi has 3 controlled fans, fan 0, 1, and 2, plus 2 always on fan connectors. A jumper V fan allows you to select whether all fans are powered from the 12, okay good, or from the Duet. So I can power them off of 12, which is good because they're all 12 volt fans. Mixed voltages are not directly supported, that isn't a problem. Okay. So fan 0 is an always on fan. No, okay, so that's 2 connectors that are for always on fans. Okay, well that's pretty simple. Thermostatically controlled fans. Alright, many hot ends require a fan, yes, that's true. Plug your fan into one of the pulse width connectors, say fan 1, and then it's thermostatic, good. So M106P1 is how you set the fan speed. And the temp, okay. And then G-code controlled fans. Okay, so fan 0 looks like that's the default for the G-code controlled fans. So that's probably what we'll hook up the layer cooling fan to fan 0. We'll hook up the hot end fan to fan 1. And then fan 2, I do have a 12 volt fan that cools down the heatsink on the heated bed MOSFET. Right now it's directly controlled by the power supply. maybe we'll change that. Maybe make it a little cleaner. Okay. My LED lights. Connecting the emergency stop button. Awesome. Awesome, awesome. I have one of those, so we'll make use of that eventually. Connecting and configuring a chamber heater. Awesome. Extruder heaters and fans. Let's see. Extruder heaters. 2-pin. Okay. So the Duet Wi-Fi out of the box controls 2 Hotend heaters, which is cool. I do know you can get an expansion for 5 more, which would be nice. What I might need to do in order to have this run the lights properly. But let's keep looking. Let's see. Do we have any GPIO pins? Nope. Power wiring, mounting and cooling the board. That's another thing that we're going to wait on. I'm not going to put the board into an enclosure just yet. I'd like to get it all up and running first. Huh, I am really surprised there's no GPIO pins. I need to see a wiring diagram. Where's the wiring diagram? Or the schematic, I guess, is what I'm looking for. There we go. Perfect. Okay, so E1, E0, heaters, end stops. Okay, those must be E1, must be, is that a filament out sensor, I suppose? Expansion, here we go. Holy cow, we got lots of pins. Temp daughter board. SPI. Oh, there we, okay, we had one, here's one GPIO, here's another, good, there's 2. And SPI. All I need are 3 GPIO pins to drive the lights. And the MOSFET that I have on the lights should be fine with 3.3 volts. They might get a little warm, but they should work. Oh, actually they will, there is a 5 volt, okay, good. So there's a 5 volt GPIO 1. Okay, here's my GPIO pins. They're going to come on this right here. So this is what I'll drive the lights with right here. So we'll use pins 6, 2, and 7 to drive the lights. Perfect, perfect, perfect. I don't think we're going to get to that today, but okay. 1, motors in series. Okay, well, I think, what's next on my game plan here? Alright, let's take a look at the ramps here. Let me, let's see if I can get this print off. This thing is really, really on there. Yeah, that thing is really, really, really on there. I was hoping that it would pop off after it cooled down, but no such luck. And this isn't tape, or this isn't glued down, this is just blue tape. Oh goodness, I don't want to break that print. Another option, I suppose, is to just lift the tape off with it, which might be what I end up doing. Well, that's what we're going to do. Let's see here. I don't want to scratch that aluminum plate up if I don't have to. Oh, I can see it releasing, but I don't want to put too much force on it and jam my hand into the lead screw and bend that. Oh, got it. Okay, anyways. So, here's Mount Rushmore. Okay. So, I'll get the camera moved over here. And I'm going to go grab a clamp real quick. Okay. Now, when I get the new firmware in there, I'm going to change the speed of the Z-axis. Yeah, and that rattle, I have not been able to figure out where that's coming from. I think it's inside the couplers. These are flexible couplers. But the lead screw is sitting right on top of the shaft for the stepper motor, and I think that noise is the lead screw and the shaft interacting. Again, please excuse my mess, but like I said, I got it up and running, and well, never really went any further than that. Okay, we're going to clamp these down. I don't want this falling on me. Okay. That should be good. Okay, so let's see, when I kill the power, we're going to be out of light. Okay, as you can tell, I'm not set up for doing this. I am set up for streaming the printer, but not for doing live streams like this. Okay, let's. Got a fancy little table lamp here. We'll set that up. Give us some light. And we'll plug it in here. And voila. Alright, let's kill the power to the printer. Okay, we're set. And let me grab my drink real quick. All right. Grab my Duet. So the reason I chose a Duet over other control boards is, well, number one, it came recommended on the CBOT forums. If you've ever taken a look there. It's also open source hardware. See that little symbol right there, and it also runs open source firmware. This will be the first time I've tried out the RepRap firmware. I've done a lot of work with Marlin, even contributed a little bit of code to it. Enjoyed it. Marlin can be a little finicky, especially some of the older versions, but you know what, it works, and this printer has done very, very well with Marlin. I think everything's going to have quirks, and once you learn them, once you work around them, you can usually find that it'll work out well. Okay, so let me set this aside, and then we'll disconnect the power supply. You can see I'm using a regular ATX power supply on this. It happens to be a Corsair CX600M. I went with the modular one because, there it is, because I didn't, well, I'm already going to have, you can see I've already got a mess of wires, and I'd rather not modify the wiring harness if I don't have to on a perfectly good power supply. So going modular, let me avoid that. Okay, now if you see here, this cobbled mess right here, this was again meant to be the temporary circuit for the Hotend MOSFET. So you can see I've got a IRF 3708 right here connected to a small heatsink. That heatsink is not nearly large enough to do passive cooling, which is one of the reasons why I've got a little 12-volt fan down here. And then put a little LED on there to see when it's active. And then I soldered the ground wire, or the return wire, off of the heated bed. The power supply is, the heated bed's positive is connected directly to the power supply, and then the negative, the return line, goes into the MOSFET, and then that's what the MOSFET. It's doing low side switching on the heated bed, and that worked out really, really well. Yeah, and I never got around to really finishing this off or finding an appropriate connector for the line in or out. When I'm pushing 20 some watts, I get a little leery, and I didn't want to worry about it, so I just soldered directly to the legs on the MOSFET. Alright, we'll disconnect that from the power supply. Actually, I don't need to. I'm just going to move that out of the way for right now. And then I've also got some LED lights. Again, they are powered directly off of the power supply. They're 12-volt lights. And then they are run through IRF 3708 MOSFETs, one each for each color. They are red, green, blue MOSFETs. And so I just prototyped that, and that worked, and so I left it. So like I said, I've got lots of things to come back for. The idea is that I will either put the LED MOSFETs on this prototyping board and run everything off of this one board, or I will I'll have a custom board made for it. To be determined, I guess. So this is the wiring loop for the LED lights. So we're not going to need that right now. So that should have all of the non-printer related items disconnected. Or non-Hotend, I guess. Okay, here's the ramps. Let's get that disconnected. We'll disconnect the LCDs first, since unfortunately we're not going to use that. I did like that. It's not needed now. Boy, this thing has only been up and running for a month or two, and it is already full of dust. Okay. These right here, this wiring harness is for the heater. No. Yeah, that's for, these are for the fans. So there's two fans on the Hotend assembly up here. There's one for the extruder, this front fan right here, and then there's a print cooling fan or layer cooling fan on the back. Those are connected with the are connected through this harness right here. So I'm going to go ahead and disconnect that. That will go into fan 0 and fan 1 on the Duet board. Okay. This should be my Z. Or no, that's the extruder. Okay. So there is the extruder wiring harness, and I thought I had these all marked, but it looks like I've removed the tape. Okay. If you're wondering, this is all of the steppers and all of the wiring harness all uses the same wire, and it's all shielded. You can see right here, it's shielded wire. Did that so that the steppers weren't introducing noise into the analog, the thermistors basically. So try and keep them quiet. Although ironically enough, the heat bed thermistor runs right along the power supply for the heated bed, but it doesn't seem to cause any issues. So okay, this green line, this is the power on lead for the power supply. That was connected to GPIO pin on the ramps here. Well, technically on the Mega. There's my Z, and you can see here what I was talking about. So I've got the Z wired up in parallel right here. This bare wire, this is the shielding wire, so there's no harm in that being exposed. And then these are the two stepper motors right here. Let's see, I don't know if you can see that or not. So this is what I'm talking about. I might need to, or I might want to break this connection right here and then run both steppers in series. Otherwise, if I want to try it in parallel, which is probably what I'll do to begin with, I'll just leave it the way it is. So that's my Z-axis there. Let's see, X has already been pulled. Here's Y, or excuse me, this is Y. Z has been pulled. There's Y. And I'm going to grab some tape and mark these before I get too far off here. I don't feel like trying to figure this out on the fly. So this was Y. So we'll mark that as Y. Okay. And if you're wondering why I didn't mark the fan lines, it's because I've already got that. I've got the whole wiring diagram written down. I created a little cheat sheet before I wired up the entire printer. So I've actually got all the wiring diagrammed out, but I don't have the wires. And when I was building it, I did have all of the wires tagged like this. Z, I don't need to bother with that. This is the extruder, so let me mark that, and then 2. That is the fan connectors there. Anyway, so the fans, you can see the colors here: red, green, black, and white. Red is the 12 volt, and then I'm just switching again on the return line, low side switching. So if I want to find out what fan these are controlling, all I gotta do is look up there, and I can match up green to green, red to red, and I'll know which one's which. Okay, let's see, I need to mark the extruder. Okay. Mark that as E. Okay. And then the last one is, of course, X. And yes, I am going to wire it. I am going to label that because I don't have to guess. Where would we be without blue tape? I tell you. I do have a PEI sheet coming. Actually, I've got 2 of them coming, but they're not here yet. So until then, I'm just going to keep using blue tape because I have not found a single plastic that doesn't stick to it. So, okay, now end stops. This mess right here, this is my X and Z end stops. Those go up to the Hotend assembly, and again, same thing. I can just look at the, oh, that pin came out. That's right, I'm gonna have to modify this anyways to add the resistors, but same wiring, 4 lead wire. And so again, if I need to see what they are for, or which color goes to which, I can just look on the end stop. I don't need to document that. This is my Y end stop. And again, I'm not going to bother taping that one off and documenting it because I don't need to. And then this, I kind of overdid it on the wire gauge. I could have used a much lower gauge wire for this. And I wish I would have, but this is my extruder heater, or excuse me, the hot end heater. I'm going to disconnect that. So, let's see, I'm going to use the trusty iFixit tool set here. Comes in kind of handy. We'll grab a spade. Or flathead, or whatever you want to call it. Okay, and just going to triple check, wiring is disconnected. Yes, you know what, I'm going to pull this just in case. Triple check, I do not want to get zapped. Power supply is off, power is off, it's still grounded though. Still plugged in, but it is physically switched off. The ramps is physically disconnected, so we should be good to go here. I only need to undo these two. Okay, there it is. Oh, that is the thermistor for the hot end. Okay, there it is. It's like doing a heart transplant, kind of. Well, in this case, more a brain transplant. Again, it's 8825 drivers, just the knockoffs, the cheap Chinese boards. And this time around, you know, and well, the whole ramps. I think this ramps plus the drivers, I think it's like maybe $25 total. And then Imitation Mega. I think this one came from Micro Center. I've gone through like 3 or 4 of them. It's one of the things I don't like about the ramps board. There's no protection. There's very little protection on there. One little miswire and poof, there goes your control board. There are knockoffs to the Duet. I chose not to buy one of those this time around because I want to support the folks that are, you know, putting their hard work and effort into designing these, and I want to reward them. You know, and honestly, I have the ability to reward them. You know, this isn't a huge expense for me, so I understand that some people that get into 3D printing or robotics or anything like that, they just don't have the financial resources to do something like that, and that's just fine. There's nothing wrong with that, but if you do have the ability, you know, go ahead and support the folks that put their time and effort into, especially, you know, into designing this open source hardware. You know, it only benefits everyone, right? You know, 3D printing in general didn't really take off until the patents wore off, and I know a lot of people, myself included, that have literally put hundreds of hours into various aspects of making the overall community better. And we're all here because, you know, somebody else has done the legwork to get us here, right? So I guess that's my little rant for now. But if you can, support the folks that got us here. So, and if not, and you just want to get into the hobby, then go for it. You know, do what you can. You know, maybe it's not financially possible to help out, but then, you know, maybe you can help out with code, or maybe support, or just getting onto a forum and helping somebody out. It all helps. So just do whatever you can, I guess. Okay, so now we need to figure out what needs to be rewired and what doesn't. I'm still going back and forth on the Z-axis, you know, doing parallel versus series. The impatient person in me says just run it the way it is, and I think that person's going to win out for tonight. When I come back and put everything into a nice clean enclosure, I think that's when I will go ahead and put the Z steppers into series. Okay, so heated bed output here. This is our voltage in. And then this connector over here must be, yep, E0, E1. Okay, X, Y, Z. Okay, extruder 1, extruder 0, X, Y, Z. Okay, good. And then fans 0, 1, and 2. Always on fans, awesome. If you remember, the documentation said that this jumper here, when it's on, I do believe that turns E0 into an always on fan. I'm going to double check that. And then we've got our thermistors. Where are those going? I need to go look at the documentation again. Holy cow, I didn't notice that it's all blown out. I apologize. Let me fix that. There we go. Sorry folks, like I said, I don't have a monitor up on the feed. Apologize for it being out of focus and way blown out. Alright, let's take a look at the documentation here. So what we're looking for is the thermistor location. So connecting thermistors. Alright, yeah, bed temp, E0 temp, that makes sense. And then we'll, okay, and where are those? So here's fan 0, 1, and 2. And, oops, can I shrink this? Can I move it over? Where's my prototype 2? Where's my scroll bar? Okay, well that's a little difficult. Let me shrink the page here. There we go. Oh, no, the jumpers are for 5 volt. Okay. We don't want 5 volt, we want VN. Okay, so here we go. Let me move this over here again. You know, I really should get some more cameras. So the jumper right here, this is voltage in or external voltage. So right now it's set for voltage in. So the voltage that comes in here is what's going to supply these fans with their, well, that's going to be their voltage. So these 3 fan connectors are going to be at the voltage potential of whatever comes in here when it's set to this jumper. When the jumper is set like on these 2 pins right here. And that's what we want, because all of our fans are 12 volt. If we wanted 5 volt fans, then I believe, yeah, okay, so if we want 5 volts, internal 5 volts on the fan connectors is this jumper, external 5 volts is that jumper there. So, okay, now E0, where's our temp, our thermistors? Where do our thermistors go? Oh, there they are. E0, E1, where's our bed thermistor? So here's the Hotend thermistors right here, E1, excuse me, E1, E0, and then our bed heater is there, and our bed thermistor is on this corner. Okay, so bed thermistor, E0 thermistor, E1. So we're going to connect the bed here, the hot end there, and we should be good to go. Extruder extruder X, Y, Z. And then what is that guy there? Okay, hot end power here. And stops there. Okay. And for our Z end stop, we've got to build a circuit for that yet. So, okay, let me take a look. Okay, so that is, well, I guess I jumped, jumped to step 4 before I did step 3, but okay, so we know what we need for the. We're going to have to build a circuit for the, or put in some resistors for the Z end stop, because that is a. We need to drive that off of 12 volts, drop it down to 3.3. We can do that with a pair of resistors. And oops, what do I need? I need wrong page. Okay. So on the wiring diagram here, our Z end stop is right here, I believe, right? Yes. So this is our Z end stop or Y end stop, X end stop, and then these E0 and E1. I assume those must be filament out sensors, because they call them E0 stop and E1 stop. So, okay. What to do next? So in order to do the Z end stop, like I said, I'm gonna have to get some resistors for that. I'm not set up to do that, and I don't want to spend a whole lot of time on that right now. So what I'm going to do is I'm going to connect everything else up and running, or get everything else up and running. For right now, I am going to go grab just a normal end stop and connect it to Z, so I can use that for troubleshooting. And I think there's also an emergency stop on here. Where is the emergency stop connected? Fan, expansion, Z probe, panel do, temp daughter board. Where is the E stop? JTAG. Alright, connecting emergency stop button. Okay. If your power supply supports power PS on, executing a G code M112 will cancel all. Okay, that's good. That's so where does the button go? Where's the wiring? Traditionally, robots use a big red mushroom, which I've got. Okay. So where? Am I just not seeing this here? I thought it said it had a connection for emergency stop. blah blah fans. Okay, I'm rereading this for like the 4th time, and I'm not seeing a pin. Note that in addition to the 5 end stop connectors, there are 5 more pins on the. Oh, okay. So you pick a pin and then configure it. Okay, good. Okay, so I'm gonna go grab an end stop so I can connect that to Z, so I can use that for testing, and then we're gonna go ahead and just reconnect all of the steppers as they're wired right now, because they've already got the correct end for this board. The end stops do not; they are just a 2-pin connector. But based off of the wiring diagram, we should be good. Depending on if they're normally open or normally closed, and I'll have to confirm that when we're wiring it. And then, because I'm assuming the firmware, we can switch the action of that pin. Okay. And then voltage in here. Bed. We'll connect the bed to here. Okay. 15 amp max. Okay, so yeah, and so this has got a 15 amp max on that MOSFET. We're pulling at least 20, if not 25 amps. So we're just going to continue using that little crusty circuit that I've got. The LED lights will connect to this header here, I believe. Yes, we're going to connect the LED. We're going to run the GPIO. Oh, no, excuse me. They're going to run off of... Oh. They are going to run off of... Oh, what the heck? Micro SD card. Oh. So these... They are not... they're not connected. So we'll have to solder some pins to that. And I do not have pins for that small. Holy cow. So the LED lights will have to wait for right now. Oh no, I take that back. We're not going to use these. We're going to use these right here. So we still need to solder in some connectors, but we're going to use the GPIO pins right there for the LED lights. Okay. So for tonight, I just want to get it up and running. So we're going to skip the LED lights. We're going to skip the wiring, creating the circuit for the Z. The Z probe. I am going to do that offline. I just want to get the board up and running. I want to see it move tonight, and then get the firmware configured for the end stop action, because some of my end stops are normally closed, some are normally open. So we'll get those configured. At least get the printer moving tonight, and then I've got another printer I'm going to print off. I'm going to find an enclosure for it, and then another night, maybe this weekend, we'll put this in an enclosure. We'll solder the pins to this. We'll get the LED lights connected to that. We will get the Z end stop or the Z probe configured correctly, get the resistors set up on that, and we'll rewire the Z steppers, change them from in parallel to in series, and we'll connect those there. So we'll button it up and make it look nice this weekend. So for tonight though, we're just going to get the firmware up and running. We're going to get the steppers moving and make it move and get it tested. So I'll be right back. I got to go grab an end stop for Z. Okay. Let me look at my cheat sheet. I know I kind of went off script here a little bit. Rewire, replace ends as needed. Yep, we're going to do that on over the weekend. We're going to connect the Duet Wi-Fi. That's what we're going to do now. We're going to power it up, do some basic testing. We're going to configure the firmware, and we'll see if we can do a test print, but without the Z probe up and running tonight, I don't know if we're going to be able to. We might have to postpone that part. Okay. Switch back to that guy. And let me move the camera down. Get that. So if anybody's wondering, though, I have the camera on a mic stand and then printed off an adapter I found on Thingiverse and then screwed that into the bottom of the camera. The camera's got the standard 1/4" mount on it. But it turned the mic stand into a nice little camera stand. Okay. There we are. And try and get this out of the way as best as I can. There we are. The wire's in the way, but that's fine. Okay, this is the end stop I've grabbed. This is called a YL99. I like these little end stops. They're normally open the way they're configured, but you can just do a quick resolder job. The switch has both normally open and normally closed, but they've only got it connected for normally open. But I don't remember which ones it is off the top of my head. But I think if you unsolder this, if you unsolder one of these legs and then connect the other one to it, then it turns it from a normally open to a normally closed. The LED light then obviously only works when it's closed, and I like that because I get to see a visual visual representation of it working. But this is called YL99. It's a nice small little end stop, and it's really useful on the moving carriages and stuff because it takes up very little space and it can just sit right on the end, and it works really well. If you do modify these, just a heads up, don't get this too hot because you'll melt the internals of the switch. On my carriage uses one of these hot end carriage for the X-axis end stop, and it must have got a little hot because the switch, it still works, but you have to push it almost completely flat before it does, so it melted the internals a little bit. Anyways, we're going to use that tonight for Z. And let's see here. And I should only need, well, you know what, I'll connect all three. That way we can have the fancy LED working. I try and use normally closed end stops by wherever I can. I've also got some keys end stops, and then the standard MakerBot design end stop. I think it's version 1.3. I think that is a normally open. But if you can, use normally closed because then they will trip if the switch goes bad, if the wire gets disconnected. You know, they're just it's just a safer way to go about it. If you're using a normally open switch, it works just fine as long as everything is connected, but if the wire gets disconnected, you will have no way of knowing. It'll just, and neither will the control board, and so you're going to crash it if that happens. Okay, so we got that. So okay, out is blue. That's our signal. And then ground is purple, and VCC is gray. And I'm going to take a look at the documentation one more time, make sure I'm connecting this correctly. Okay, end stop is ground, voltage, and then signal. And ground is towards VN. Okay. So ground is towards VN. So there's VN. So we're going to orientate that way. Ground is on the left or on the right hand side then. And ground is the middle pin here. So ground, gray was VCC, and purple was signal. There we are. There is our temporary Z end stop. Here is my Raspberry Pi that I was using to control the ramps or feed the ramps. This is Octoprint. Very, very nice. I'm going to continue using it if I can. Although I'm looking forward to trying out the Duet's web interface. Okay. Z. There's our Z. There we are. We're connected. Y. Come on. Alright, there is Y. Got it. X. I'm really grateful that I marked these now. And we got a huge, I need to get these shielding cables connected to ground. They're not really doing a whole lot unless they are. But they make me feel good. Feels like I'm doing the right thing. Come on. Got it. Okay. X, Y, Z, and extruder. Got it. Okay. That that is, I don't remember what that is now. Oh, why didn't I mark that one? Okay, end stops. End stops are right here. And if I look up on the, look up here, Z uses red, black, and white, and X uses green. Okay, so green is what we want. So the green wire, so this is my X end stop right. Yep, there's the green wire. So this is my X end stop. So we've got to switch these two pins around right here. So we need ground over here, VCC there, and then signal. So I gotta pull that out. Alright. Make sure I got the right one. Green, okay. Try not to stab myself here. And I should have grabbed the spade, not this side. Yeah, I'm going to grab the spade. Okay. Alright, again, I'm going to double check. You can see the heat shrink that I put on here is also color coded. I did that on purpose. Sure makes this a lot easier. But again, I don't want to fry anything, so I'm going to double check anyways. Okay, now hopefully I didn't. You know what I'm going to do? I'm just going to go get their ends and I'll just swap the ends out completely. So I'm going to pull all these pins out. Oops. Got it. And if you ever need to, there's the trick that I use is to push this female end in all the way and get underneath the little opening in there. That's the catch for the plastic bit. And usually I can get that plastic bit to pop right up. And there you are. And these things are usually only, they're not really reusable, I've found. You can maybe get 1 or 2 changes out of them, but you know, they're not really durable. So, and they're not really meant to be. So, okay. So here is the ends that came with it. There's the triple that we want. Seal that back up so I don't lose any. There we go. And now to get orientation right. So again, this is how that's going to go on. Ground is towards VN, and it goes ground, VCC, and then signal. So ground, and I'm hoping these are the same connectors, although I don't think they are. No, they're not. I know the connectors that these are. Shoot. Shoot, shoot, shoot. Alright, I'm not going to rewire these tonight. I'm going to use the black connector again for now, and then over the weekend I will recrimp new ends on. That's going to be a lot of fun. Okay, so ground. Okay, got it. And then VCC. Got it. And then signal. And again, I'm not going to bother with the Z probe right now. I still need to build a circuit for that, so, well, not a circuit, but I need to do a voltage divider on that. Okay, so this is X, so Z, Y, X. There we are. And ground is towards VN, or VCC, in, so we're good. Alright, Y. Where is Y? I wonder if that was the mystery one. This guy, that's what this is. This is Y's end stop. So I need to swap these two around right here. And again, if you are typing into chat, I apologize. I am not able to see it. I will check here in just a minute or two. Come on. There's got to be a better trick to this. I thought I had it figured out. There it goes, got it. Okay, I'm just going to push that up for right now. And we'll push up VCC, got it. Oh, came back down. There we got it. Well, that one's doing what it's supposed to. Go back down and catch. Now it's not. Okay. Ground. And wow, this is going to be tight. push those back down. Catch, good. And Y. Okay. So, just double checking. So ground is the purple. Got it. Gray is VCC. We got it. And blue is signal. We're good. On Z, on Y, we've got black, which is our ground return. Red, which is our VCC, and green for signal. And then on X here, again, green is signal, which is goes to the purple because I didn't have any green wire. Black is ground, and the gray here goes to VCC. So we are good on that. So Z is connected, Y is connected, X is connected, the extruder is connected, our end stops are connected. So the next thing we need to connect is we'll do the thermistors next. Actually, let's do the heaters first. They're going to be a little more difficult. And then we'll get to this last. This concoction here is the ATX interface. Okay, I should really have a workbench. Well, I do have one. It's in my garage, but this printer is far too big to be moving around, and in this state, parts would fall off. Classy. Okay, so here is our hot end. Again, this is way too... I went a little nuts on the wire gauge, but I did not want to worry. So, and this is our thermistor, and then we are going to connect. We're going to connect this to these wires to our bed output, and then this MOSFET will actually control the bed. So we don't need this big connector, or we don't need this MOSFET, but I don't. And if there's enough GPIO pins that then I can remap the bed, then I will probably remap the bed output to a regular GPIO pin, either a pulse width pin or just a straight GPIO, doesn't matter. Because I'm using Bang Bang for the bed. It's a nice big thick aluminum bed. It doesn't really need pulse width. It only varies by maybe 1 degree in Bang Bang. It's plus minus 1 or maybe 1.5 degrees, so there's about a 3-degree spread roughly, and that's fine. And it's about a 30-second hysteresis, so I mean it's not bad at all. So, okay, hot end. Maybe I should have done that first. Oh well. Okay, so we need extruder 0, which I'll double check the wiring diagram, but that should be extruder 0 there. And that should be extruders. I better check the wiring diagram. Yeah, extruder 0 is is closer to VN, so we are good to go. So I'm guessing that will need a. Yep, it will. Let me grab the correct spade bit here. I don't know if that's the proper term, but that's what I'm giving it. This is the connector we want. We'll just back it off, make sure it's open. And this wire might be too damn big. VN? E0VN. I think I might have missed something there. Okay. Sorry, I was just double checking the wiring diagram. See if it mattered. Well, it doesn't. It's just a resistor, but okay. So we're going to put, this was marked VN, so that's where I'm going to put the low side. Okay. Oh, please don't pull out till I get a chance to tighten you up. Okay, we're good. Okay, that's cinched down. That is cinched down. We're just going to double check, make sure there's no stray wires. Let's see here. Hang on for 1 second. Figure out how much it is anyways, I guess. Alright. Sorry folks, my son came home and he works at Culver's and brought me this. Nice raspberry shake. Good kid. Alright. So there's just one little stray wire on this red lead. It freaks me out. So I'm going to take that out. And we're going to make this nice and purdy again. And we'll try it again here. I might need to shorten up that wire just a little bit. It might be a little bit long. There, we got it. Got it. Let's try this again. Oh, come on. Go in there nicely. Okay. Yeah, I gotta. I don't know why this one's being the black one went in nice and clean. This one is not. There, I got it. That was the ticket. There we are. Okay. I'll cinch those down a little bit more. Okay, good and good. Okay, that is the hot end, and the next is the bed. Let's see the LED lights. We're going to put those. You know what? I'm going to make that a proper. We're going to do away with the breadboard, and we'll just we'll put that on a prototyping board at least and get that looking a little cleaner. And maybe I'll make a housing for it. All right. You know what? I'm not going to hook the bed up. I'm not going to print tonight anyways. And I'd like to clean up the wiring on the bed. So I am going to skip the bed for tonight, which means we've got end stops, we've got steppers, and we've got a hot end, so just a hot end thermistor at this point. And we can start testing. Oh, I gotta turn that around. I gotta shorten up my wires. There we go. The hot end thermistor, this is the bed thermistor here. The hot end thermistors are right here. So let's go ahead and connect that. There we go. Okay. All right. So we got the hot end thermistor. We've got the hot end. We've got X, Y, Z end stops. And we've got no VCC in yet because we don't want VCC in yet. We've got the extruder stepper, X, Y, Z steppers. Okay, let's go ahead and wire up the VCC in. Raspberry shake, so good. Alright, so we're going to disconnect the little ramps. the connector that was on the ramps here. And I'm going to steal this power supply has got 2 rails. And I'm going to use both of them. I'm using both for the bed anyways, even though according to the power supply specs we should be able to get away with just one. I know this is ugly, please forgive me. Okay. Alright, and this is the power on, or power supply on lead. No, this is the power, no, let's see, which one of these? This is the PS on, I think this is the constant 5 volt. And then this is an extra ground, which I should have trimmed. But let me see if I need it first. For right now, put a little tape over it. And I do have proper electrical tape. I don't have it with me, so blue painter's tape. It is a 3D printer's duct tape. Okay, let's go ahead and connect the VCC in here. And ground is towards me, VCC is away. And the terminal is this a closing terminal? Screw close, looks that way. Okay, so put VCC in first. Okay, that is connected. Oops. So if you're not familiar with the different terminal types, so there are some terminals that screw down to close, and this one screws up to close. So, and I've worked with FRC, First Robotics, enough that they do the same thing depending on how big of a gauge the wire is, the use of it. It seems the bigger gauges do the, you know, if they've got a screw block like this, they will, you screw and then the terminal closes going up, versus this guy here, when you're turning this, you're actually pushing the, you're closing the terminal down. This closes the terminal up. Alright, so that is connected. Let me look for the power supply on lead in the diagram. See if we've got that documented. Oh, we do have an external 5 volt, so we're going to go ahead and connect that. The power supply has a constant 5 volt output, so, and this has a constant 5 volt input. So we're going to connect that, and that should power the Duet even when the power supply is on. So VN and ground is going to be controlled. The Duet will be on anytime the physical power switch is on the power supply by using the 5 volt rail right here, the external 5 volt supply rail right here, and then the PS on pin. Oh, this is PS on. This is constant 5 volt. So, and then this, the Duet will control the power supply via this pin. When this goes low, the power supply comes on, and then this will be supplied with voltage. So the Duet is always going to be on. Bob, we got to find the power supply on connector. Oh, that was really good. Okay, let me look at the documentation here. Oops. Standby power, that's what I was talking about. Okay, if the main power supply supports an ATX PS on, you know what? I bet. Oh, right there. Awesome. Okay, so we're gonna have to. I am going to use. That's why I've got this ground out here, is so that I can connect. I'm going to connect all three of these to this pin right here. That will. So these three wires will go into this, and then the power supply will supply 5 volts via this line right here. Will be at a constant 5 volts in. Then this is the PS on lead, that goes in the middle, and then ground goes right here. And then that will allow the Duet to be always on anytime the power supply is physically turned on and plugged in. It'll also let the Duet control whether the main power supply rails are turned on in the power supply. So, but for tonight we're just going to connect the PS on, because we are going to power the Duet over USB and test that it can turn on the power supply. So, okay, that is that. This is for the fan, so we're going to leave that connected. Okay, end stop. This is the bed thermistor. I guess there's no reason not to connect that. It's not going to hurt anything by being connected. This right here is for the LED lights, so we don't need to worry about that. We'll go ahead and connect the bed thermistor. And you know what? I'm just going to connect that stupid thing. I'm just going to go ahead and connect the bed. So give me a second here. I'm gonna. These will be some sacrificial connections. Where's my? There it is. grab the wire strippers. I'll be right back. Alright. So, I just went and got everything. Oh, I forgot the solder. Hang on. I gotta go grab solder. I'm gonna go ahead and connect. I'm gonna put these three into a connector, get that connected. I'm also going to strip some wires for this connection over to the bed heater. Let's see what else. Yeah, I think that's all I need to do. But in order to do this, I gotta solder a little bit of wire because this wire comes out of this ATX connector is way too thick for the for those pins or the crimps, the crimp-on ends. Hi. Going to bed?
Streaming?
Yep. I'm connecting up the new control board.
So you're streaming?
Yeah.
Because yeah, Overwatch is still not too hot.
It's time for bed there, kiddo.
It's not even 10 yet. You still Steam downloading?
Hang on. Sorry about that. Alright. I've got two teenage sons. And one of them was coming down to complain that Overwatch was not fast enough for him right now. The problem these kids have nowadays, I tell you. Okay, now we've got... So this MOSFET is also doing low side switching. And so, but if I look at the LED, I do believe that I should have marked this when I took it off so I know which one is positive. This should be positive here. Oh no, this is ground. So this is positive, yellow is positive, blue is ground, green is nothing, and I did not need to strip it. Oh, come on. Seriously. There we go. Green doesn't go anywhere. Doesn't even need to be connected. Okay, and the bed is marked VN and bed negative. Okay, so I gotta think about this. If that is doing low side switching, then it's not, there's no power going to this. Then this isn't going to trigger. There's no supply voltage. VN and bed negative. Okay, I see what they're doing. So they want you to have VN here, so one of the supply rails on this pin, and then the bed negative goes there. Why? That doesn't make any sense. I gotta look at that more. Okay, so I'm gonna skip the bed. I gotta figure out exactly what's going on. But I can do these. So let me get this. Let me get the soldering iron heated up. Okay. And while that's doing that, I'm going to take the tape off. I suppose that's going to leave residue all over the wires. Ish. Alright, so I'm gonna strip that off just a little bit. This one's already ready to go. And we can replace the pin on this as well. So we'll go ahead and cut that one there. We'll solder a small ground to this and then put heat shrink tubing on that. I gotta grab my solder. Okay, sorry, I went and got the right colored heat shrink tubing. Okay. Solder, heat shrink tubing, and the iron is warming up. Alright, black. Okay, so I got my black wire. And where's my wire strippers? There they are. Ah. Got it. Let's see, I'm going to cut that down a little bit, make sure that's even, or even it out. Alright, yeah, we'll strip that off. Ooh, way too much, way too much. Ah, come on. There we go. Okay, now I'm going to tin the wires. Oh, the tip of this has got to get cleaned. The solder's going to be... Okay. Got it. What'd I do with that black wire? There it is. I should really grab my little helpers. This is going to be next to impossible. Hey, that'll work. Actually, let me look at that. Eee, no, that won't work. I really should just go get my little helpers. Come on. Alright. Please don't judge me. There, we got it. Alright, I'll be right back, folks. I'm going to grab the little Okay. And where's that wire at? There it is. Got it. There we go. Oh, the tip is so filthy. I gotta get that cleaned. There we go. Oh, come on. There we go. That's much prettier. Much more pretty. Alright. Yeah, it's not perfect, but it'll work. And my knife. Where's my knife? My laundry room has turned into a workbench, and I can't find my knife. Okay, well. I am going to resist the urge to go get the heat gun, though. We'll just use the we'll do this with the soldering iron. Crank up the heat. There we go. Okay, that should be good enough. Okay, now we can trim these all up to about roughly equal. Okay. I know. There we go. Got it. And we're about to get to the fun part. I still need my knife. There it is, found it. So I don't know if any of you have ever done these before, but I'm gonna grab 3. I know that's optimistic, but I'm an optimistic kind of guy. Alright, there's the crimpers. Okay, everyone, I don't know if there's necessarily a wrong way to do this, but I usually put, actually, you know what, first, a little prep work. I think that's solid. These are all solid core wires, aren't they? Yep, they are. Okay, good. So I don't need to twist to make those all nice and pretty. But I like to put the end in the crimper in the proper spot and give it just a tiny little crimp right to begin with. And we'll feed this in until it stops. There we go. And look at that, folks. Look at that. Oh, you know what? I'm going to crimp that with the smaller one. That needs a little more crimp to it. There we go. Might be a little over squished. Way. That's not going anywhere. Okay. So I don't know if you folks have used this, but so this crimper's got, you can see the die that's set in here. So these ends have got, they actually have 2 crimps on them. One is actually a crimp for the wire, that's the inside crimp, and then this outer crimp is meant to crimp the jacket of the wire itself. So, or the insulation. So what you want to do is you put this in there, and I crimp it just a tiny little bit, and that closes these inside wires just a little bit. Push the wire in until you can feel it. You might feel it go through this one first. The insulation or the jacket of the wire hit this one first, but it should stop when it hits this one inside. So when I put this in here, and then you can see these little the change in size of the die. So the insulation crimp goes on the larger part. The wire crimp goes on the inside part. So I put these in here, close it down just a little bit, and then I pull it out until the crimp catches on that inside die. We want to make sure it's straight, so it's crimping straight. Okay. And if we can, we want to try and make sure it's the same orientation on the wire, so we're not having to twist the wires. And now I'm going to put this in, and these wires might be a little long. Okay, it just went past the first one and it stopped on the second. So I'm going to go ahead and crimp. And you can see how that inside crimp is done. That inside crimp is around the wire. The outside crimp is started on the insulation. But I don't know, this is not, normally that's the right die, but maybe I don't have the right ones installed on this crimper. There we go. Now we gave her a good crimp. Now the insulation crimp is really nice and tight. Actually, it's a little more tight than it needs to be. You can see it squirted out the side here a little bit. That can be a problem because it'll flatten flatten, distort that, and then it won't fit in the housing. So what you saw me do earlier with the pliers is just try and round it out a little bit so that it'll fit in the housing well. So again, I'm putting this in there, flat side, so I'm putting it the orientation with the teeth down, making sure that the top part of that, or that it's orientated straight on. So it's sitting flat. So it's sitting like this inside that crimper. Okay. So I'm going to come down, make sure it's straight. It's crimped just a tiny little bit. I'm going to pulling on it that way so that the crimp for the insulation catches. Putting this in there. The wire should slide in. Then then it just clicked in. When I say clicked in, that means the insulation went past and hit the crimp for the wire. Now we're going to go ahead and finish off the crimp. And we're going to inspect it. Again, the crimp for the wire is done. It's wrapped around the wire. The crimp for the insulation is about halfway done. And these are locking crimps, so I need to complete the cycle before it open back up. I could release it early, but that's not necessary. And there we go. And we got it. We're good. Okay, good night.
Good night.
Okay, so that is done. So we can grab our housing. And we need the 3-wire housing, that guy right there. And now we're going to check the orientation of the housing. So the housing is going to go on like this. PS on was the middle. PS on is the green. I'm going to double check all the wiring. This is definitely ground. I believe ground was this one, and then that should be constant 5-volt on. But let's check the PS ATX power supply wiring and the wiring diagram. Alright, so you can see this is what we're wiring up right now. So constant 5-volt is away from the power in, VCC in. PS on is the middle, and then ground is the terminal next to the power in. And let's just double check that we've got the right wires on the ATX supply. So ATX. There we go. And if we're looking at the connector out of the power supply, the side with the catch, PS on is the green wire. Normally it is the green wire, but don't assume. But anyways, it's the 4th wire in, so it's technically it is wire 13, 15, 17, wire number 19. So we're going to double check that, and then constant 5-volt is the red, or excuse me, is the purple. This is +5 VSB. That is the constant 5-volt. So anytime the power supply is physically plugged in and physically switched on, this is always going to be supplying 5 volts. And this green wire is constantly monitored. Anytime that PS on wire goes to ground, it turns on the power supply. Alright, so let's double check our ATX wiring. Okay, so you remember it was the side with the clip. That is this side here. And so this is pin 1, this is pin 13. So 13, 15, 17, the green wire is our PS on. So that goes to the middle. So we're going to orientate the plug, and then we'll go ahead and insert this. Now these go in like this. Okay, so there is a little catch on the back of these connectors. Okay, that catch falls into that slot right there, and that locks that connector inside the housing. Okay, so we're going to go ahead, push that in, and I definitely did tweak that. There it is, and it just locked in. I don't know if you heard it click, but it just locked in. Okay, so again, I'm going to orientate, make sure we got the right. Okay, and then we are going to go ahead and connect ground, or yeah, put the ground pin or ground connector in the housing, and then the constant 5-volt. And let's just double check. That is 1, 2, 3, 4. It's the purple wire. So this is, again, this is pin 1, because here's our catch. So pin 1 is here, 3, 1. Oh, you know what? This must be 1, 2, 3, 4. That doesn't go 1, 2. So I was wrong. This is actually, PS on isn't pin 19, it's pin 13, 14, 15, 16. Pin 16. Or wire 16 or whatever, so. Anyways, we're good. Yeah, I tweaked that one as well. So I over-crimped these connectors just a little bit, so I'm going to try and straighten them out. Not too much though, because if we don't want to fatigue the metal. So, and I don't want to loosen that crimp on the wire. That should do it. And I'm going to go ahead and let's tweak that just a little bit more. Okay. There it goes. Got it. Okay. So there's our. So again, if we're double checking, there we go. Oh, I did wire it wrong. Dang it. All right. Even after my double checking, I still got it wrong. Maybe it's best not to talk and do this at the same time. Yeah, I got them wrong. Okay, well, here's how you pop them out. So again, we got to push this catch down and try, and we need 3 hands for this one. We've got to push the catch down and try and pull the wire out at the same time. Can I get lucky? And I can't push down too hard because, nope, there we got it. Good. And there we got him. Okay. Okay, and ground. Yeah, I pushed the, so on this one I pushed the catch all the way down. Now I gotta flip it back up just a little bit if I can. I don't want to have to redo the wire, or redo the end. Oh, I couldn't have made this any more difficult for myself. That ought to do it. Alright. Got it. Okay. So, ground, PS on, constant 5 volt. We are good to go. There we are. Okay. This is, again, this is our those are our fans. Sorry, I had to think about that for a second. You know, there's no reason I can't connect those right now either. Alright, let's see which color. So red. Red and white go to, okay, red and white go to the layer fan, and red and black go to the Hotend fan. So we want red and black. I need to switch these around. There we are. Those were constant on. These were the temporary ones. Okay, we're good. And again, I'm glad that I put the ends on for the replicate, which has the, because it sure is coming in handy now. Yep, okay. And I'm going to double check the wiring and make sure I've got VCC correct. Okay, yep, so fan 0 is, okay, we're good, we're good. Voltage, and the jumper, VN to VFan. Okay, good, awesome, all right. So the wiring diagram doesn't say that this is the positive, it says VFan. And why it says VFan is that VFan connects to this pin, middle pin right here, okay? And with that jumper on here, what you're really doing is, okay, do you want it to be supplied by the onboard 5 voltage or 5 volts, or do you want it to be on VCC in? So if you move the jumper over, then it's a 5 volt fan. Move the jumper to the right, it's whatever voltage your VCC is in. So the way we want it right now is VFan on the right, VFan on the right on this pin, excuse me, VFan on fan 0 on the right, VFan pin is on the right on fan 1. So we are good. These are ground, these black and the green are ground, so we are good. So that means we're going to have a 12 volt. Because of this connection, we're going to have a 12 volt fan pulse width on both of these, which is good. Although we might want to move this one over because we don't care about pulse width on fan 0. We just want that to be on or off. But for right now, this will work. So the only thing we don't have connected right now is the Z probe and the bed heater. And we're going to leave it that way because I'm going to try and use a GPIO pin on and use this MOSFET instead. So okay, let's go ahead and connect the ATX power supply. And we're going to live dangerously. Okay. Oops, let's connect that back up. Okay. Oh, I see. Oh, that connector's right. We're good. Come on. What the heck? Why is that being a bear? Alright, what's going on here? Come on. It doesn't like these middle pins for some reason. Ah, I see why. Okay, so what's happening is that this was an ATX extension cable, but when I'm moving these wires here, it's reorientating the pins. So I've got to watch that and try and get these lined up. Yeah, actually I have bent a couple of them over now. So let's fix that. Okay. Say we're looking good here. Okay. Come on. Oh, come on, man. You were supposed to make this easier. Alright, well, they're all straight now. Oh, there we go. Okay, no wires sticking out. We're good. We're not connected. None. All right. Here we go. Okay, well, that's honestly not what I was expecting. The Duet should have powered up. Alright, let's take a look at the power supply again, or the wiring diagram. Jumper, external 5-volt. Oh, okay, I see. There's a jumper we gotta hit. So right now we are using internal 5-volt. We want to switch this over to use external 5-volt, it looks like. So we're going to pull this jumper from here, put it on. So I moved it from here to there, and there it goes. There we go. You can see the lights are on. So she is powered up. Okay, now we're going to connect the USB. And let's start talking to it. So we're going to plug into the Raspberry Pi again because, let's just face it, they're awesome. I'm actually a BeagleBone fan, but the new one is not out yet. Or the Beagle board, excuse me. Okay, let's go ahead and plug this in down here. And now we probably could have done all the configuration without it being powered on, but I wanted to see if my wiring was good, so could have powered it up over USB, but there we are. Okay, now we'll do the rest on the computer for right now. So. Oh, sorry, I forgot to switch the. All right, I'm going to move the camera. There we are. And we are going to switch over to. Alright, well, it's probably not a whole lot of fun to sit here and watch. There you go, there's my ceiling. Let's do this. Let's I'm going to enter the wireless settings. I have nothing against you folks. I just rather not have random people connecting. Okay. And what am I going to call this thing? It was Pi 34 before. We're going to call it... You know what, we're just going to leave it Duet Wi-Fi for right now. Okay. properly. I can see that we don't. So this is our thermistor right here and right there. You can see that we do not have anything connected to it because for some reason I connected this to the filament end stop of the filament detector. We want it right there. All right, let's go back and take a look. don't know why OBS is acting up on me here, folks. Keeps crashing. Do not know why. Yeah, it looks like the audio might have been down. Okay, anyways, so I've disabled. I've disabled the. What the hell, man? All right, let's take a look at the forums. I have a hard time believing that the hardware is dead. Oh, hey, there you go. End stops. Oh, okie dokie. Okay, that one's good. Oh, that's working. Well, all my end stops are working. The LEDs aren't very bright, but they are working. Okay, I don't know, I guess I could disconnect them. Let me disconnect. Just occurred to me that I still got the Z probe. Okay. Thermistor. End stop. Okay. I still have the Z probe end stop powered. I might have to redo the wiring for that one. Anyways, I physically disconnected it now, so. Nah, it doesn't matter. It's still not happy. What the hell, man? Oh, what the hell? I'm gonna disconnect the end stops. I don't know what's going on. Okay, I have disconnected all the end stops. And let me reset it again. I don't think it's an end stop issue. I think I did something. Alright, there it is. Let's try ACM3. Nope, done. Dead. Oh, device or resource busy. Okay. Well, that's more encouraging. Busy is okay. Octoprint, you're not getting in the way, are you? No, you stay offline. Okay, good. That's not complaining, so good. Well, I'll be damned. There she is. It's alive. It's alive. Okay. What the hell? Was it the end stops? Could it be the end stops? I do not know. Hey, look at that. Okay, so let me spin you guys over here. So I don't know if you hear that noise, but that noise is the power supply that I just turned on via the M80. And that very loud fan, that is the 12 volt fan. It's an old case fan. It's noisy. Okay, so let me switch this. So you can see, well you can't see, but you see the blue lights on the left hand side of the board? That's the power supply on. So let me shut it off with an M81. And blue light goes out. And you can see the fan stop spinning. So we are good to go there. So let's go ahead and turn on M80. I'm going to turn on the Wi-Fi. I turned on the Wi-Fi and it went boom. Okay, so let's double check. Let's double check stuff here. I'm going to bring you guys back over here. Whoa. Okay. Alright, as soon as I enabled the Wi-Fi, it reset itself. So, let's put things back the way they were. Printer is now online. Okay, good. So, can we do file manipulation through G-code? Oops, wrong one. you've downloaded the correct firmware before installing it. The Duet Wi-Fi firmware bin should be 208 kilobytes in size. That doesn't. So here's the problem with that. According to the documentation, it's 288. I'm going to assume that that's, yeah. That's 223. Is that the only branch? Yeah. Okay. Okay, so the official DC42 binaries of the main firmware Duet are available at, okay, that's where I got them from. Chris Ham intends to produce a Duet Wi-Fi build of his fork of RepRap firmware. His releases are at blah blah blah. Wi-Fi module firmware is available here. Link TVA. Okay, so let's do this. What G codes can I run? Okay, so RepRap firmware, that's what we're running. So I need to look at their documentation. RepRap firmware, G code. Can I do file manipulation via G code? Heaters, Ethernet, miscellaneous. Web control, firmware configuration, geometry, miscellaneous, movement, heating, miscellaneous, non-specific. Retract, this is all printer stuff. Operation, probing, printing, physical, heating, configuration. Oh, nope. Alright. Okay, so I'm gonna kick the SD card out again. I'm gonna revert all of the firmwares back to the way they came originally. I'm gonna restart it, enable Wi-Fi, see if it's stable. If that configuration is stable, then I'm going to shut it down, reconnect my end stops, fire it back up, see if it's stable. If it's stable, then I can only assume that the firmware files that I downloaded are they're no good. And I suspect it's the Wi-Fi firmware file that's no good. So I'm going to revert that one first. Okay, that's disconnected. Waiting for it to power down. Alright, and it's down. Yeah, this was all going pretty smoothly up until I decided to update the firmware. I'm not blaming the firmware. I'm not saying it's anyone's fault in particular. Sometimes bad things happen, but I'm a little concerned that I downloaded the official firmware, put it on here, per the instructions, and the thing went boom. That is a little alarming. Okay, so that is the exact same file, or exact same size. Let's see if it's the same file too. Hang on. Let's do some diff foo here. Diff Wi-Fi server. They are exactly the same. There are no differences between those files. There are differences in the firmware. So there's no reason to have the new Wi-Fi server.bit on there, so I'm going to remove it. They are literally the exact same file. Okay, and we'll put the other one back in its place. Okay. Okay. Well, I really wanted to test this configuration first. So let's do that. This shouldn't matter. They were the exact same file. So even if the encodings were different, you know, if it downloaded as a text file by accident, diff would have caught that because they would be different files. But diff is saying they are the same file. They're same content at least. So maybe the Wi-Fi firmware is toast. Oops. Yeah, it's not much bigger. Alright, let's try this. Okay. There's my hotkeys. Okay. F, shift F1, F2, F3, enter upgrade. Okay, got it. Sorry, just setting my hotkeys. Okay. And yeah, I know the message in the upper left-hand corner is old. I'll fix that here. Okay, let's fire it up. Okay, ECM3. Okay, it's alive, so at least it's starting up nicely now. M552S1. Let's try it. See what happens. See, the fact that it doesn't come back and tell me anything, there's no return, is a little alarming. So we'll give it 30 seconds here. Yeah, it disconnected the serial. Restarted and came back as TTY4 or A. Okay, so it is online. I'm thinking that this is me. I am misinterpreting what this thing is doing. I don't see it. Okay, printer is online. Okay, I don't see the Wi-Fi yet though. And you know, another option could be that since it's connected to the Raspberry Pi, it's possible that the control board is pulling too much power from the Raspberry Pi. The Pi can't fully power it, and that might be why we're getting really weird behavior out of the Wi-Fi. That makes a lot of sense because you turn on the Wi-Fi, it resets because now we're drawing too much power via the USB. And I think I just figured it out. I hope. So I've turned on the power supply now, so it should be supplying 5 volts to the board. Still don't see that. Okay, let me try this again. M552S1. Okay. Oh, yep, it did disconnect. Came back at 3. Okay, we're online. I don't know, man. It's 1 o'clock in the morning my time. But I really, really want to see this thing up and running. M552S1. Yeah, see this, I'm not seeing the Wi-Fi server starting up message. Alright, let me do this M997 firmware flash. Updating main firmware. M997S0. Alright, let's try this. Okay, updating main firmware. Is it supposed to reset itself that quickly? I don't know. I do not know. I know it's 1 o'clock in the morning. Okay, printer is now online. Okay, can I turn it on? Yeah. So I can turn on that. Okay. So let me move this over here. Holy cow! Didn't realize that this would go up so high. Okay, so I'm gonna point the camera over in that direction because my new goal. My new goal is to make it. You can see the cabinet that I built for it. Alright, I'm going to make it move. I just want to see it move, and then I think I'm going to shut it down for the night. How about that? Okay, we got a problem with the one of the motors is turning the wrong direction, but wow, that is quiet. Holy crap. That is really, really quiet, except... Okay, so let's fix this. Let's get... So it's moving. So this is... Okay, I'm going to connect the end stops. I don't think the problem was the end stops because the problem is still happening and the end stops are not connected. So we are going to connect the end stops. Okay, so ground is there. So ground is here. So ground signal and VCC. Okay. no, that's wrong. These two are wrong. These two are wrong. This goes there. Okay, and this. Okay, there we go. So we have Z end stop connected. We're good. The Y end stop. Okay, and Y end stop is good. And now the X end stop. Okay, and I need to change that behavior because this is a normally closed switch. Okay, so I should not be able to move this in the X direction now. Oh, it doesn't care. It's moving anyways. Let's see here. Not stopped. Why is X not stopped? X is triggered right now. I should probably shut the motors down before I did that. Okay, now. Alright, so X. Alright, X is good. Well, it shouldn't be letting me do that. Okay, temperature graph. Bed and ext0. Okay, so I'm going to set this to 60 degrees. Now we don't have the fan turned on, but look at that. There she goes. Awesome. Oh. Fantastic. It's the wrong fan. Okay, well, I've got these fans backwards. There we go. Awesome. Is the fan turning the wrong direction? I can't tell. Nope, that's good. Nope, that's good. Okay. Okay. So the fan works. Good. The PID needs to be updated a little bit. But it is at 60 degrees. So let's bump this up to 170. And then I am going to try and extrude. And I'll go to 180. Well, let's just go to 200. There we go. 200. Oh, look at that. Let's shut it down. Error. Heating failed on heater 1. Temperature rising much more slowly than expected. 1.4 degrees per second. That's a little, that's a little, yeah, that is a little, so what did it do then? Did it cap it at 60 degrees? Hmm. Okay, well. Oh, that's not gonna work. Okay, we gotta fix the movement first here. I'm a little concerned that the temperature for okay, printer is now online. The temperature for the extruder is not going down. Whatever this error did, it appears to have left the extruder on. Yeah, it's definitely warm. It's not hot. But now I don't have any control over it. Let's find out what's going on. No, that's not going to work, but you know, whatever. Okay, I want to know why is this? That's a rep wrap thing. So let's go check it out. Rep wrap firmware codes. Rep wrap. Where's the documentation for rep wrap? Cheat code. Typical. Okay. Oh, it shut down. Awesome. Why? M105. Oh. Did it? where's my temp for the hot end? What? What? Okay, so M562 resets the temperature fault. Okay, so let's do that. Okay, so we're just gonna have to do some tweaking. Yeah, M562 reset a temperature fault on heater / sensor. If the rep has switched off and locked a heater because it has detected a fault, this will reset the fault condition and allow you to use the heater again. Okay. So M562P1 is what we gotta do. Well, that's kind of nice. M562P1. Are we good? We do not appear to be good. M562P1 does not appear to have reset that fault. Okay, what the heck? M562, reset a temperature fault on heater / sensor. If the rep has switched off and locked the heater because it detected a fault, this will reset the fault condition and allow you to use the heater again. Well, I disagree. M562P1. No response. No okay. Just okay. What's the G code for resetting the entire thing? Erase the EEPROM. No, that's not what I want. Set EEPROM offset. No. Okay, no, that's not what I want. Restart after being stopped by error. Okay, let's try that. M999. Okay, that's it. TTY3. Okay. Okay, we are online. Okay, M80. Okay, we're powered up. Temperatures are looking good again. Awesome. Okay, motors are off. Okay, so let's fix the movement here. So, okay. Connecting stepper motors. Here we go. Using external drivers. Yada yada yada. To remap X, Y, or Z. Nope. Okay, we're not doing that. Okay, where's core X, Y? Okay, configuring for core X, Y. Okay, the method of setting up simultaneous homing is different for core XY. Okay, we Commissioning, no. Okay, use S1 for core XY, S2 for core XZ. If any motors move the wrong way, you can use M569 commands to alter the directions. The X motor, okay, let's try that. Let's check out M569 here. M569. Okay, so M569, set the control value for the drive specified by P. Okay. Set the control value for the drive specified by P that sends it forward to the given value in the S field. After sending the example, sending a 1 to X, drive 0 will make it go forward. Sending a 0 will make it go backwards. Okay, so the R parameter is not supported by all firmware, but in the DC Newman fork of RepRap, okay, or the DC42, this sets the enable value, logic level. For the following example, drive 2 is enabled by sending in. Okay. Alright. Okay, so M569P0. So let's change X first and see if that gets us going in the right direction. M569, oh, M569P0, right? P0S S1. Okay. And let's move X to the right. Okay, well that's not correct. So let's try S0 then. Hey, look at that. Oh, crap, what are you doing? Not sure what button I just hit, but it wasn't the right one. Alright, oh, that was Y home. That was not the correct button. What I wanted to do was this. Okay, that's good. Okay, and Y forward. Nope, okay, Y is backwards. Oh no, that is correct. Alright, we're gonna home X. Nope. Okay, so why is it moving this? Why is Z moving on a home to X? Okay, I'm resetting it because I want to see if it, after it comes back online, if it stored the configuration. So I did make a configuration change to fix the movement of X and Y. And then I did an M500 to save it, and if everything is going correctly, then I should be able to enable the motors. So turn it on. M80. Okay, so it's on, and now the X should move positive. Nope. Okay. So it did not save. It did not save the settings. So M569. P0S0. Okay, that should fix it. Yep. Okay, good. Okay, that is a little bit off. Okay, we better figure out if we are relative or nope, we're absolute. Okay, good. Rock on. I do believe this is kind of quick. This is getting a little ridiculous now. Alright, that's as fast as should go. 16,000. Plenty quick. Plenty quick for now. That's awesome. I kind of like that. Ooh. Okay, so we might have to bump up the amperage a little bit. Alright, does RepRap firmware, does it do G28 for homing? Let's take a look. G28. Buffering, move to origin, or origin. Okay, I'm a little leery on doing this because it moved Z when I tried to do a home before. So let me do this. Let me move these guys a little bit. Okay. Boy, that is really tweaked, isn't it? Yeah, those wheels are tweaked. Yeah, I need to adjust those again. Okay. Mr. Lamp, you need to go. You need to go. You need to go, my friend. Let's see, I do want to use it though. So let's do this. Let's put it up here for now until I get my LEDs working again. That is a poor substitute, but hey, whatever. Okay, we're going to do a G28X and see, let's hope for the best. Okay, so why, so the homing sequence is a little bit strange. It moves Z up and down. I'm guessing it moves it because it doesn't want to crash the head. So, all right, we'll have to update the home all sequence. So I need to get back into this thing, and so we need to get the Wi-Fi back up and running again. Or I need to pop M. Well, you know what? I want to take a look. I want to see what M500. Is M500 different in RepRap firmware? Set PID. Okay. Oh, hey, look at that. M307, set or report heating process parameters. Cool. Alright, M500, where are you? M502, M503, print. That's what I was looking for, M503. So it is the same. M563. Okay, so you see this right here, M569P0S1. Okay, so M569. So it has not saved this. P0S0. Oops. Okay. And then M500. Stored back. Okay. Alright, so M500 should store it. Okay. I'm just double checking here to make sure that I don't see anything. Okay, so M500 should save this then. Oops. Okay, so if I do M503 again now, M503, it's still set to, what the hell, man? Okay, okay, read parameters. Okay. So M501. Let's pull them out of the config file again. Okay, now M503. Print them. Nope. It is not updating the config file. Whoops. Okay. No kidding, huh? G1. Alright, so G1, S2, X10. So according to this, this isolates the X motor and should move it 10. Yeah, and that's exactly what it did. Very quickly, I might add. Cool. Alright, so this should move Y then. Okay. Awesome. Cool. Alright. See, I don't like that I don't get any confirmation on this. I would expect to get an okay. This prompter face. That's what I wanted to see. Okay. M552 S1. I can only assume that this is bad hardware at this point. It worked one time. And now as soon as I enable the Wi-Fi, it resets itself. The end stops are working as expected. They are triggering correctly. The thermistors are working. Everything else is working. But the Wi-Fi resets. I don't need it to print. I can print via Octoprint. But kind of defeating the purpose here. Alright, here's what I'm going to do. I am going to disconnect the camera, and I'm going to plug the Wi-Fi, Duet Wi-Fi, into the USB extension and into this computer and see if I can talk to it directly from here and enable the Wi-Fi, because I'm losing my mind here. So I need this. There goes. There we go. Got it. Okay. We're good. So you don't need to. So there's what I've done. I don't know if you see that, the USB cable there. It's a 10-foot extension that I have running over to the streaming. I've got a PC designated just for streaming. Alright, you know what? I never did get rid of that. There we go. Okay, so we've got the Duet Wi-Fi connected directly to. Here's what we want. I've got it connected directly to this computer now, and I believe we need to install a couple of drivers. Let's go grab those. Whoops. Oh, if you get a chance, print this off. This is really a cool print. I printed it off at 200% and it turned out great. Let's see, there we go. Okay, download duet.inf and duetinf.cat. Okay, so let's go grab that. And I should be able to pull this down as a zip, but alright. What the heck, man? Alright, we'll go this route. why is this not giving me the option of, okay, save, okay, there we go. Okay, we're good. Oop. Too many windows open, man. Where am I? Losing my mind, man. Okay. Under Windows 10, you can install it by opening the folder in File Manager and double-clicking on duet.inf. Okay. Now, what the heck, man? Oh, yeah. Install. Open. Yes. Fantastic. Okay, we're good. Connect the Duet Wi-Fi. Okay, so now I'm going to disconnect it. And we'll reconnect it. And hopefully we get the magic happy Windows sound. I do not see the device. Oh, okay. What are we doing here? And check in Device Manager that's correctly recognized. It should show up as Duet 3D. Okay. While that's going, I need to download Pronterface. Device Manager. Alright, what should it show up under? Should show up at, okay. Check in Device Manager that's correctly recognized. It should show up as Duet 3D Printer. Control Electronics. Okay. Where though? Nope. 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 Okay, there it is. Well, coming in on COM3, which is Okay. COM3 it is. Okay, so M503 is supposed to give me output of the config.g. Okay. M552 S1 go. Okay, nope. Nope, 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 nope. Nope. Alright, I need to... Well, we're going to start over here. What the hell? Okay. Alright, so what I'm going to do is I'm going to completely reset this thing back. I don't know what... Okay, so there's why Z is moving. That's what I suspected. So Z is moving in the wrong direction. Okay, so let's fix that. So X, Y, Z. Temperature. Okay. So we're gonna eject this, put it back in, do an M997 to flash the firmware again. I don't think so. Oh, yep, wait a minute. Damn it. All right. I'm gonna go grab another small extension. I'll be right back. Okay. Power down. Power down. Yeah. Okay, we're online. Okay, so it's supposed to be flashing itself now. I don't know how long that process takes. I'm guessing not very long. Okay. Cool. I don't think M went, or Y is homing correctly. Okay, I'm not sure what's up with Y, but it's definitely not homing correctly. Okay. Oh, because X and Y are triggered. X definitely should be, Y should not. Y is... Alright, I want to see if M552 S1. Please work. Nope. Boom. Alright, I'm calling it a night. There's no reason that, I can only assume that the Wi-Fi went bad. I'm done. Good night, folks.